All right, so we are going to learn how to simplify radicals. So your notes look like this, and really they're just practice problems. But before we start, I thought I would go over what simplifying radicals actually means, the square root. So if you have two numbers that you multiply, they're the same, and 3 times 3, okay, and you get 9. The square root of 9 is 3. What that means is, think of a perfect square. That's what we call a square root. The side lengths are 3 and 3. The area of that square is 9. So the square root of 9, what number multiplied by itself gives you that number is 3. Now perfect squares have you can take the square root of them, very simple, very easy. It's square root of 81, for instance. What's the square root of 81? 9, because 9 times 9 is 81. So it's a good idea to have the perfect squares memorized up to, 100, okay? Because, even 11 times 11 is 121, 12 times 12 is 144, pretty much up to 12, okay? Because it's going to make your life a lot easier. Now, a lot of times you're going to be asked to simplify a square root that is not a perfect square. For example, 1, this is a perfect square, and you're done. But a number like 27, that still has to be simplified. Now, if I were to simplify square root of 36, what we're doing is we are breaking up 36 into two numbers, a pair of numbers, and then once we have that pair, when we pull it out, there's 1. So it's just 6. For 27, we need to think of what two numbers when we multiply together, we get 27. But one of those numbers needs to be a perfect square so we can pull it out of the radical. Because this is not going to be, 27 is not a perfect square. So once we simplify this, we're still going to have something left under the radical. So the first two numbers I think of are 3 and 9. 3 times 9 is 27. Well, 9 is a perfect square. So what is the square root of 9? The 9 can come out. That's 2 3s, right? But we still have that 3 left under the radical. So the simplified square root is 3 square root of 3. Let's try 50. 50 can be broken up into different numbers. And we've got to pick a number that's the largest perfect square that goes into 50. Okay, we could pick 10 and 5, but that's not going to help us because neither of those two numbers is a perfect square. We need a perfect square. So I'm going to break up 50 into 25 times 2 because 25 is a perfect square. So 25 comes out. The square root of 25 is 5. Comes out. And the square root of 2 is left. Square root of 100 is a perfect square. Square root of 20. We could break that up into 10 and 2. But how's that going to help us? Well, what about 4 and 5? 4 and 5 might work. 4 times 5. Pull the 4 out because 4 is a perfect square. That's 2 root 5. 32. 4 times 8? 4 times 8, we'd have to break up again. What about 4 times 4 times 2? Hey, there we go. So that's 16 times 2. Or you could break it up if you want to think of it as, I was just thinking of it when I broke it up into 4 times 8, and then in my head I broke up 8 into 4 times 2. Perfect square right here, pull it out, and it's going to be a 4 root 2. And moving on. 45. 9 and 5. 9 times 5. Square root of 9 is 3. So it's 3 root 5. 8 is 4 times 2. Square root of 4 is 2. So that's 2 root 2. Square root of 30. We could do 10 and 3, but that's not going to help us. So I'm going to give you guys a couple seconds to see if you can do the square root of 30 and square root of 12. Now keep in mind, some radicals cannot be simplified, okay? Alright, so you go through in your head and you're like, alright, well, that's 10 and 3. What are some other numbers that I can multiply and get 30? I can do 5 times 6. But again, I'm running out of problem. I don't have a perfect square to pull out, so that's just already simplified. Now 12, we could do 6 and 2, but neither one of those numbers is a perfect square. What about 3 and 4? And pull the 4 out, so that's just 2 root 3. Moving on, rationalize the denominator. Okay, so a lot of times you have to manipulate a function or an expression, and one thing that comes in useful a lot is when you rationalize the denominator. So a lot of times you'll have a radical in the denominator and you can't end up with a radical in the denominator. So you're like, what am I going to do here? Well, we can multiply by anything by 1. So I'm going to multiply by a special 1. I'm going to multiply by root 2 over root 2 because I'm getting rid of the radical in the denominator, because root 2 times root 2 is square root of 4, which is 2. Done. Can't be simplified. 12. Multiply by special 1. 6 root 7 over root 7 times root 7 is just 7. Try the next couple problems. You might want to press pause before I give you the answers. Now that one can be simplified because I can simplify 3 goes into 3 once, 3 goes into 6 twice. So this is equal to the square root of 6 over 2. Now, what I would do for the last few problems is simplify them first, just if you can. So you can divide radicals. As long as they're both radicals, you can divide them, or numbers, you can divide them. So what I would do is change this to the square root of 1 over the square root of 2 goes into 10 5 times. This just becomes 1 over root 5. Well, now we can rationalize, and we get root 5 over 5. This one can be simplified to the square root of 4 over the square root of 1, and that's just equal to square root of 4, which is 2. 3 doesn't go into 11, so I'm going to have to, I guess, rationalize the denominator. So that's square root of, now 11 times 3 is 33, and the denominator is 3. Now 33 doesn't have any perfect square factors, so we're done. This can be simplified first. I'm going to do square root of 1 over square root of 3. This 3 goes into 9 3 times. And this is 1 over root 3. Multiply by special 1. And if I'm going too fast, you just need to pause. Why can't I move the trash over? There we go. Alright, I think that's it. Okay,